Okay, so for our class today, we will talk about quadratic sequence. So I have a sequence over here, and how do I know that what sequence is this? And how do I know that this is a quadratic sequence? Now we have to work something out over here. Now to know what sequence is this, you have to work out the term-to-term rule first, okay? So here to here, the term rule that's gonna give me +1. Here to here, that's gonna be plus 3. Okay. Now immediately over here, you see something already. Okay, you know that the term-to-term rule is not the same over here. So you know that this sequence is not a linear sequence anymore. But let's not worry about that. Okay, let's continue to work this out, and then let's see what do we see. Now over here, that's going to be +5, +7, and over here +9. Now we can see over here for the blue marker that the term-to-term rule is different. So for this one, we will call this the first difference. Okay, we will call this the first difference, okay? Because like how do I get one? It's the difference between these two numbers, right? That's the first difference over here, okay? Now, despite having no pattern over here, but what if I work out the second difference? Now the second difference is gonna be over here. And when I work out the second difference over here, you will notice this will be +2, +2, this will be +2, and this over here will be +2 as well. Okay? So if you notice in this sequence that the second difference is all the same, and that is the key point to identify that this sequence is actually a quadratic sequence. So I'll make a note over here. If the sequence have the same second difference, and then we can say that the sequence is a quadratic sequence. Okay, so that is the rule over here for us to identify whether the sequence is quadratic or not. We have to check the second difference. As long as they are the same number, they are the same. Now I want to highlight this a bit. When I say that they have the same second difference, it can be like this as well. This can be 1, 1, 1, 1. It can be, it has the same second difference. That can be a quadratic sequence as well. It can be -3, -3, -3, -3. That can also be a quadratic sequence. Okay, it depends on the sequence you get, okay? But as long as they have the same number, regardless it's a positive or negative number, it is a quadratic sequence, but they must be the same, okay? Now over here, since we now know how to find how to identify a quadratic sequence, now how do we find the n-term rule for a quadratic sequence? Okay, like again, if I'm interested to find the 10th term of this sequence, all right, what should I do? All right, what should I do? Is there any way that I can get the 10th term of the sequence like directly? Okay, so yes, there is. So before that, we need to construct the n-term rule of this sequence first. Okay. Now, before I show you the formula of what should we do to find the n-term rule of this, I'm going to prove to you. All right, I show you how the formula comes about. Now, since we are talking about a quadratic sequence, you might be familiar with this word from your factorizing topic. All right, we have learned how to factorize a quadratic expression. So you should recognize this form over here. ax squared plus bx plus c. Okay, that is a quadratic expression. But since we are interested in a quadratic sequence, instead of the x over here, we change it, all right? We change this to n instead, all right? We change this to n instead of x, okay? It is because we are interested in the sequence and the n over here representing the term in that sequence, okay? Now what you are looking at over here right now, an squared plus bn plus c, this thing over here, that's the n term rule for a quadratic sequence. So basically your final answer will look something like this lah. Okay? So what's your end goal? What do you have to find, all right, to complete this? So your goal over here is to find the value of A, B, and C. Okay, that's your goal, all right? So you need to use this information over here to find the value of A, B, and C, plug it in to this quadratic sequence, okay, and n terminal of this quadratic sequence, and you will get the answer, okay? So how do I do that? How do I do that? Now, over here, I'm going to show you a proof of how do I find A, B, C over here, right? Now, we know that this sequence is called quadratic sequence, so they must have something to do with this, correct or not? So let's write an expression, all right, to represent the numbers over here, okay? So what I'm going to do is this. I will have term 1, term 2, and term 3 over here. So basically, I am going to write an expression to represent the number of term 1, the number of term 2, and the number of term 3. Okay? So since this is the general expression to express the n term rule, so if I'm interested to find the expression for the first term, my n is going to become 1, right? So let me write that down first. So if I have A, my n going to become 1 square C. Okay? Okay? So what am I going to do now? I'm going to expand this. So if you expand this, your final expression, you will get A plus B plus C over here. Okay? So this A plus B plus C is the expression to represent the number of the first term over here. Alright, or in other words, I can say A plus B plus C, it's equals to 7. Okay, that's what it's representing. Okay, now why am I doing this? Okay, because again, what's our end goal? I want to find what's my A, B, and C. So I'm going to use this expression to help me to find eventually. Okay, but let's continue to construct our expression first. So for our term 2, so n is equals to 2 now. So I'm going to do this. And then I will have plus B. Then I will have 2 over here and plus C. Alright. So I expand this, I should get 4A plus 2B plus C. Okay? So this expression is representing the number 8 over there. So last one for term number 3. So by the time my n is going to equals to 3 now, so I will have A, okay, just substitute. Okay, and then you expand this, you should get 9A plus 3B plus C. Okay? Alright, now what do I going to do next? is I'm going to continue with this. I'm going to find the expression to represent this 1 over here, the blue line over here. So let's come back to this. How do I find 1 over here? I will take 8 minus 7, that will give me the 1, correct or not? So same thing, how do I find the expression over here? I should take this expression minus this expression, and that expression should represent this 1 over here, right? Because that's how I get 1, 8 minus 7. So I should take this and minus this. So if I do that, 4a minus a, I should get 3a. 2b minus 1b, I should get plus b. C minus c, they will cancel out each other, okay? So this 3a plus b is the expression that represents this 1 over here. Now the last one. Okay, over here. So I will do the same thing, this expression minus this expression. So I should get 5a plus b. Okay, c and c will cancel out each other. And the last one over here for this 2, for the second difference, what is the expression for me to represent this? How do I get 2 in the first place? It's 3 minus 1. So I can do the same thing over here as well. Okay, so if I have this expression minus this expression, I should end up with only 2a. Okay, alright. So I'm done with all here. Now why am I doing all these things here? Remember what's our end goal again? We want to find our a, b, and c. And so the important formula for you to know and to use, alright, it's this 3 over here. Okay, it's this 3 over here. So right now, I'm just going to write down a summary for your reference. I'm going to show all these things. I'm going to summarize what am I trying to say over here. So the summary of the formula is going to be this. So I have my A, B, and C. Alright, and that will be equals to 7. Alright, but I do not want to write 7 over here because I want to write a general a word for me to express this as a formula. So 7 here is the number of the first term, correct or not? It is equals to the first number of the sequence. Okay, that is what A plus B plus C is equals to. And then my second one, I have my 3A plus B. Okay, and this expression is equals to this. Alright, it is equals to the first number of the first difference. Okay, so this is equals to the first number of the first difference. And finally, I have my third one, which is 2a only. And this expression is equals to the second difference over here. Okay, so right now, this is the formula that you will be going to use, alright, that you are going to use to find the A, B, and C for the n term rule of this quadratic sequence. Okay, so right now I'm going to show you how to use this now. Okay, so since I want to find what's my A, what's my B, what's my C, so what I'm going to do, I'm going to work my way from bottom all the way to the top. So I will start from here and then I will end from here. Now why do I do that? Why do I start from the bottom? Because my bottom has only one unknown. Alright, I know that in this case 2a is equals to 2, correct? So I can work out what is a directly, and since I have my a, I can work out my b, and when I know my a and b, which I can put in here, I can work out my c. So this will give me all my a, b, c values, okay? So that's how we find the n term rule of a quadratic sequence. Right, so let's try over here. So for me to find my A, so this is how I would like to write it. For me to find my A, so I know I will be using this formula, that's the start. So 2A is going to equals to the second difference. So in this case, it's 2. So that's equals to 2. So my value of A is going to equals to 1. Okay, so I have found my A. This is done. So let's B and C. So for my B, I will move up because I know my value of A, I can find B now. So for me to find my B, that's going to be 3A plus B, and that is equals to the first number of the first difference. So in this case, that's going to be 1. So this is going to be 1 over here. So I know that my number of A is 1. So this is how I'm going to write it, 3. And then I substitute A, which is 1. And then plus B is equals to 1. So if I want to simplify this, so I'm going to get 3 plus B is equals to 1. And B is equals to negative 2. Okay, 1 minus 3, that's negative 2. And finally, since I have found my value of B, one more alphabet left, I'm going to find C right now. So for my C, I'm going to use the last one over here, A plus B plus C. So I will have A plus B plus C, and that will be equal to the first number of the sequence. So that in this case, that will be 7. Okay? So I already know what's my A. So my A is 1, so I'm just going to replace 1 over here. Plus, I know what is my B, which is negative 2, so I will put negative 2 over there. And then am interested to know what's my C, and that's going to equals to 7. Okay? Now we can work this out very quickly, and you should get C, it's equals to 8. Alright, you should work this out, and you should get C is equals to 8 over here. Okay? So with this, what have I done? I have already found my value of A, B, and C over here, which is the information I need to make my n-term rule of this sequence. Correct? So what am I going to do now? I'm going to substitute my A, B, and C to this expression over here. So this is how I'm going to write. So I'll put a 3 dots over here. So this 3 dots means therefore, my quadratic sequence is an squared plus bn plus c, and I'm going to put everything in accordingly. So my A over here, that's 1. So that's going to be basically 1n squared, alright? So my B over here, that's negative 2. So it's going to be plus negative 2, alright? And don't forget the n outside, plus my C, which is 8 over here. Okay? So what am I going to do next is I'm going to expand this, alright, to make it to become an n-term rule of a quadratic expression. So my final answer should be n squared, okay? And over here, plus minus, that will be minus 2n, and then plus 8, okay? And then plus 8. So this one over here, okay, that is the n-term rule for the quadratic sequence. Okay, this is the n-term rule for the quadratic sequence, okay? Now with this n-term rule for this quadratic sequence, we can find any term we are interested in. Okay, you can find 10, you can find the 100 term and whatnot. But what I always do to make sure I'm correct is I will always double check this. Right? How do I double check? Just choose one of the term you're interested in. So in this case, let's just say I'm interested in this term 4. Alright, just for example's sake. So if I'm interested in term 4, which means n is equals to 4, if I substitute n is equals to 4 over here and I calculate everything, will I get 16 or not? If I get 16, which means my n-term rule is correct. Okay, let's work this out very quickly. Now we can do this very fast over here. Okay, n is equals to 4. So 4 squared, that will give me 16. Right? Okay, minus, that's minus. Okay, so 2n. So 2 times 4, that will give me 8. And then I have plus 8 over here. And when you simplify this, true enough, this and this will cancel each other, and what I'm left is just 16. So which means this tells me that this answer is correct. Okay, which means this n-term rule for this quadratic sequence is correct. So that is how we find the n-term rule of a quadratic sequence. All right.